Friends, how we doing? We are looking at compound inequalities. Good. When we look at them, these ones are going to have some special fancy solutions similar to the ones that I did on the board the other day for you. Okay, so let me show you this. So first we have, we're going to number one, part A. When we graph them, we don't want to create rules for what the graph looks like based off of the words and the direction that they're pointing. We want to read it and interpret it, and then graph it and interpret the graph based off of the words. Okay, there's a very clear distinction you need to have. So here we go. This first one, x is less than 0. So we're going to turn around. If I have here, here's 0. So we're going to do an open circle on that. Less than is going to shade to the left. Now, if I check this one out in blue, we're going to turn around and we're going to do x is greater than or equal to -2. So I'm going to take -2, greater than or equal to as a closed circle. And we're going to go to the right. The word and, if you remember, the word and means the overlap between the two, the intersection between the two. If we just want the intersection, we just want the part that they overlap where the blue and red comes in. So it would be this all the way to that with an open circle. So our final solution as graphed would look like that. When we turn around and write this in interval notation, we're going to go from left to right on it. Now, anyways, let's do part B. Part B. So when we look at it, remember, we're going to read it, we're going to graph it, we're going to interpret it. Okay, we're going to actually read and interpret the math and the words that happen. So we're going to read this right here, this red one. X is less than 0. So we're going to take 0. We're going to graph an open circle. Then we're going to graph less than 0. Now we're going to take the next one. X is greater than or equal to -2. So we're going to graph -2. Filled in circle, we're going to do greater than. This one has the word or. We have the word or, which means we take all of the parts of all of them, the union of all of the potential solutions for each and every one of the statements that's located in there. If we do that, if we take the union and the inner, like all of them, all of the parts, it's going to end up filling in the whole graph, filling in the whole graph. This one is all real numbers. Okay, that is the effect of the middle word that shows up in there. So when we go ahead and we're graphing, when we go ahead and write the interval notation, the one on the left, the interval notation is -2 with a bracket to 0, parenthesis, because we don't get there, it's an open circle. And the one on the right is all real numbers, so we're going to go -infinity to infinity and beyond. Okay, here we go. What happens? Here's another special scenario with part C on numero 10. So we're going to graph the one on the left, -5 less than or equal to -5. Okay, so we'll drop that like it's hot. Then we have x is greater than 7. We're going to put a 7 there, open circle. That says to the right. Now read and interpret the graph and the words that are part of the statement. The word is and. And means the overlap, the intersection. Is there an intersection of this graph? No, there is not an intersection on this graph. So our answer is no solution. And I like folks to take just their marker and put an X on the graph to say, whoa, I shouldn't have done all that. Interval, 0 to 0, parentheses. All right, here we go. What happens when this whole thing changes to an or? -5, filled in circle, 7, open circle to the right. Now we have the word or. Remember, the word or is the union. So all of the parts of all of them. So we just leave it. We drop it in there and we just leave it. We're done. It's an or. And then we turn around and write the interval for that. -infinity, -5, union of those two things. Ooh, it's a bracket right there. What's that? Bracket to infinity. Okay. All right, let's keep it going full steam. Here we go. When you do these, please note that there are like two totally separate parts to this. And at the very end, we're going to write them with a word or in between because the problem itself has the word or in it. So at the end, when we find the solution, the algebraic solution with the inequalities all simplified with x's all up by themselves and whatnot, we're going to drop the word or next to it, just like at the beginning of the problem. It has the word or. So now, so let's do this. The blue one on the left, we're going to add 7 to both sides. 5x less than 20. Divide by 5, divide by 5. X is less than 20. We're going to leave that one by itself. We're going to drop to the other side of the OR and get working on it. We're going to get jiggy with it. So we have negative 4 is x is greater than 11 minus 3 today. 11 minus 3 is 8. So now we're going to divide by negative 4. Negative 4. Oh, check it out. Check it out. Did you see it? Do you see it? Besides the fact that that becomes negative 2, do you see what needs to happen? Did you see that? Did you see that? Did you see that? That right there, it flipped. It flipped because we divided by a negative, and we got to flip that. So when we finish this problem off, x is less than 20 or x is less than negative 2. Remember that, don't erase it all. Remember that word or is absolutely crucial. Without that word or, the result of the problem can totally change based off of what's up here. Okay, so now we go ahead and we take that, we drop that on the number line, we do them in their parts. So this one, x is less than 20, open circle to the left. This one over here, red, x is less than negative 2, open circle here. Now this is a curious scenario we have going on here. Very curious, isn't it, my friend? Very curious. Notice how they're both pointing the same way. Do you remember what we said when we said the word or up above and we talked about what the word or represented? You remember? It means all of the parts of both of them. If it's all of the parts of both of them, notice how the blue one is shaded to the left and it just keeps going to the left. And it writes over, if we were to keep it going, it's writes all over that red one. So this is super curious. So the final answer here is actually this. Now, this gets really crazy because we can't leave these two separate inequalities